In this video, we're looking at rational indices, that is, exponents that are rational numbers. The learning intentions that we have here is the same as the index laws, to understand the rules for manipulating exponential expressions. And the success criteria is that we can use the rules for manipulating exponential expressions. So just some housekeeping, let's talk about some terminology that's going to be used. We have this power here on the left, a to the power of 1 over n. So we can formally refer to this as a to the nth root. Now this expression here on the right just says the same thing, the nth root of a. So if we have a to the nth root, we can go one step further and say that if we incorporate the third index law, raising a to the nth root to the power of m, then changes our index to this rational number m over n. So a to the power of m over m, n. Now this, written in this form with our radical symbol, the nth root of a to the power of m means the same thing. Now the significance of this, of incorporating the third index law, is that if we have a to the nth root and raise that again to the power of n, then this gives us the original base that we had to begin with. Let's apply this to some examples. So negative 13b.1, evaluate the following. Negative 64 to the power of 1 over 3. So this is actually asking us to find the cube root of negative 64. That is, what is the root number that were to be cubed would be negative 64? And the answer is 4. You can check that. Negative 4 times negative 4 times negative 4. Part B, 9 to the power of negative 1/2. So this negative index can be rewritten as 1 over 9 to the power of 1/2 with a positive index. And 9 to the power of 1/2 is the square root. So we're looking for just what number squared is 9? 1 over 3. C, 16 to the power of 5 over 2. So we can first break this into the (16 and 1/2) and then to the power of 5, and perform each of these separately. 16 to the power of 1/2, so the square root of 16, 4, and then 1 times 5, so 4 to the power of 5. Evaluating this, 1024. In these next lot of examples, we have the added bonus of needing to use prime decomposition. So let's break down our, in the example A, we're being asked to simplify, so let's break down our 6 and 16 into their prime factors. So we've got 3 to the power of 1/4 times 2 times 3 to the power of 1/2 times 2 to the power of 1/4. And all of this is over 16, so that would be 2 to the power of 4 to the power of 3 over 4. Okay, so what can we cancel out here? 4 and 4. And, all right. So our bases in the numerator here, 3 to the power of 1/4 plus 1/2, 3 to the power of 3/4, and then 2 to the power of 1/2 plus 1/4, 2 to the power of 3/4. All of this is over 2 to the power of 3. So, if we were to rewrite this in a slightly different way, we could say that this numerator could be 2. So instead, currently it sits as 1 over 2 cubed. So this could be the same as 2 to the power of negative 3. So that's actually going to subtract from our 3/4 here. So when we simplify this, the 3 3/4 stays the same, and we get 3 3/4 times 2 to the power of negative 9/4. But we like to write our answers with positive indices. So let's say that this is equal to 3 3/4 over 2 9/4. Okay, let me just tidy up that little bit of red there. Okay, example B. We have two products here. And the right-hand one is, let's write that down with a rational index. So 5x squared plus 1 times 5x squared plus 1 to the power of a third. So using the first index law, we could add the power of 1 and a third. So 3/3 plus 1/3. 5x squared plus 1 to the power of 4/3. And our last example for today. Let's step through this simplification. First of all, let's expand out each of these brackets. X to the power of -1, y to the power of 1/2, times x to the power of 4 over y to the power of -12. This could be rewritten as x to the power of 3, and then y to the power of +12 plus 1/2, or just x cubed y to the power of 25/2. Okay, so we've just brushed through those very quickly. Let's just summarize what we looked at. We looked at rational indices, that is exponents that are rational numbers. We expanded on the learning intention from last time to understand the rules for manipulating exponential expressions. And hopefully, after practicing a few, you'll be able to use the rules for manipulating exponential expressions. So jump on the mini quiz. I think there's 2 questions there. Have a go at them, and then tackle questions 1, every second one, 2 and 3 from 13B. Thank you.